Welcome back, everyone. This is Calculus 3 at College of Sequoias, fall 2022. We're continuing our lesson on 12.5. This is the derivation of our other version of Kappa of T. If you don't care about the derivation and you just want to use the formula, you can skip this video, although any good math student wants to see it. So I thought I'd show you how we get Kappa of T to equal the magnitude of R prime cross R double prime divided by the magnitude of R prime of T cubed. Okay, so let's take a look at it. Recall three different things. The tangent vector T is R prime over the magnitude of R prime. I'm going to rewrite this by clearing the fractions, and R prime of T equals R magnitude of R prime of T times tangent T. I'm going to call this equation A. We're going to do some substituting here in a second. Also recall that the normal vector is tangent prime over the magnitude of tangent prime. So we rewrite that without fractions. And finally, kappa of T, the original kappa equation we had, T prime over R prime. I'm rewriting this again without fractions. So I've got equations A, B, and C. So what we're going to do is we're going to start off with R prime of T and take the derivative. Okay. So, and right away, before I take the derivative, that's obviously R double prime, but we can do the substitution thing here also. So this equals the time derivative of this bit right here. So I've got magnitude of RT times T of T. Why do I have an extra line right there? That doesn't belong. So we distribute like chain rule. So we've got the derivative of the magnitude of R prime of T times T. So we took the derivative of the first, left the second alone, and then we're going to leave the first alone, take the derivative of the second. So my left side is R double prime of T. My right side is this sum. I see this T prime of T right here. We're going to come up here and grab it, equation B, and plug that in for this value right here. And if we do that, the only part that really changes on this line is this T prime of T becomes the magnitude of T prime of T times the vector N. Everything else stays the same. And then we've got T magnitude of T prime. We're going to grab that from C. C's got magnitude of T prime is kappa times the magnitude of R prime. We're making that substitution right here. So we take the T prime, and I'm plugging in kappa, and it makes the R prime get squared. So right now we have R double prime equals the derivative of the magnitude of R prime of T times T of T. And then we've got plus R, the magnitude of R prime of T squared. So this is a product still. That was just an underline to highlight. And then it's times kappa of T and times the vector N. That's our R double prime. So where are we going with this? We're going for we're looking for this. We've got R double prime. Let's cross it with R prime. So we're going to do R prime crossed with this R double prime. Okay. So here's my R prime. And again, I'm using equation A. And here is everything we had right there. This is equation, I called it D. This is equation D. And remember, when we have the cross product with the sum, we can distribute the cross product to each. So we have R prime of T, the magnitude of R prime of T, the magnitude of R prime of T derivative. And then we've got T cross T. That's this right here with that. And then we distribute this T cross T to the other section. These are all constants, so they get pulled out front. This R prime right here matches up with these two R primes right here, so we get an R prime cubed. That looks familiar, right? We're looking for a cube. We've got kappa of t, and we've got now t of t is crossed with n of t. We're almost there. The cross product, remember, has the sign of the angle between them. The angle between tangent and tangent is 0. Sine of 0 is 0. Any vector crossed with itself is 0. So this entire first part goes bye-bye. Bye-bye. So now we have the second half, and t cross n is b. So we'll make that substitution real quick. So maybe pause it there, so let you finish writing it down if you are. Okay. So right now we have r prime of t cross r double prime of t. All that's left is kappa of t, the magnitude of r prime of t cubed, and b of t. We will now normalize it. We needed the magnitude of this. So we take the magnitude of it. The constants, the first two things are just constants. We square them, we take the square root. They come out all fine and handy dandy, just as is. Then we have the magnitude of b of t. But remember, the binomial vector is a unit vector. So it has a magnitude of 1. So we have r prime of t cross r double prime of t equals kappa times the magnitude of r prime of t cubed. We divide by r prime of t cubed, and we get the equation we were looking for. That's the derivation. There's a lot of steps to it. There it is. Peace.